All right, great. Um, let's just like jump into it right here. And first, before I do it, have you looked at this one at all, or is this still like pretty fresh to you? Okay, no, that's actually expected and probably makes it better for these purposes. Pretty much the goal of this lesson, I think everything before was basically the syntax of the language and some like semantics in terms of this, this does this. And what we're going to see today a little bit more is like kind of knock as it's actually used and kind of what are some like best practices, some common patterns that come in, how how you can use it to make actual programs and build it up because it's very composable. So it definitely you definitely tend to make it in this very building block fashion. So before I go into that, just start, at the top here, we have a quick reminder. Something we're going to use a lot is this idea that, if I have this, equal set the face increment formula to the thing, then I can just use it as I do right here. And I can, run with 50 as the subject, run that increment formula, and it'll substitute it in. So the reason I mention that is that it's real, like if I scroll down here to like the kind of code we end up making by the end, like it looks like stuff like this that I have highlighted right here. So it's, and it gets even even like much longer by the end for this final thing that we end up building. So that's fairly hard, hard to grok or piece together, but it's a lot easier if you can kind of build each thing in pieces and assign them to variables and then just kind of output it all at the end by getting the value of all those variables. And that's, A, it's just nice, but B, it actually showcases something really nice about Nock that we're gonna like see, which is that you can isolate all the pieces of it very easily. So what we're going to do is just to go over the basic Noc pattern and then start into some programs. So the basic Noc pattern is that you set up a core to do everything, and then you go ahead and run it. Okay, so everything that we're kind of okay. So I'm trying for my separate laptop too. Okay. Um, am I seeing everything there? Tell it. Just let me know if I'm getting everything you're saying because I'm not looking at the Twitch right now just to keep the screen. Okay, cool. Um, this is a little bit different than the ways that we've done things to this point, which would be more like we kind of do arbitrary formulas where yeah, no, it looks really good. Should really wish I could do it like this normally. Arbitrary formulas, where we'll have like, something like this, and we say, okay, get me the thing in memory slot two or stuff like that. As opposed to that, this is going to be a lot of work to set up a core, and then the final command will be like, okay, now go ahead and run that core. And what that lets us do, crucially, is this lets us embed variables and loops, and like even and gates actually in our core, and then refer to them in different parts of the core. Okay, so the question that people always, I think, that feels weird when you start making a real Nock program is, how can I do variables and looping in Nock? Right? How do you have the concept of I'm running code, but I might want to run it again? And the answer is that you set up a core with that code that has like an if condition that decides at the end whether to go and run that same core again. Okay. My chat's a little slow, but we should be good right here. Let me just refresh it. Okay, did it miss? Is it just eating my message? This is a hit of damn it problem. Um, okay, cool, got it. So the first program that we're gonna do is we're gonna make just a simple increment gate. Okay, so so we have this increment like code that we've seen a lot of times, and I'm going to highlight here, which is just this 401, seen it a million times in Nock. And what we want to do is we want to turn it into a gate. So I want to ask just two things Socratically here. um, First is, why would we want to make a gate when we already have code that can run against a subject. Like I can already, say I have the number 98. I can do 401 as the formula and get 99. So tell it. Why would I want to make a gate rather than just using this code that already works, which knows how to take a number subject? And I'm just going to dot post in here occasionally. Yeah, that's like we want to pass new subjects. Um, yes. Now, although at the same time, like you could easily have a random subject and say and do something like a 7. So let's say what I'm going to do right now is I'm going to put in the dojo. My 98 is now going to be kind of trapped inside this other thing, and we've already seen how we can kind of get at this, which is you could use something like um, a Noc 7 to say first. I'm going to be live coding a bit, so there might be a mistake, but okay, that works good. So I'll just walking through this code right here. We could use a Noc 7 here to say what Noc 7 does is it's basically composition. So it goes ahead and runs the first formula and then runs the second formula on the result of the first formula. So first formula is 02, that gives us 98. And then it goes ahead and runs 401 on that. Okay. So we do have a way to just use our normal increment and not have it be bespoke. Yeah, okay. Resolve other knock in the position once we can have nested code. This is close enough that I'll pretty much give it full credit and explain it. Essentially, the reason is that our increment code is going to be in a battery. Okay, so if we have the usual thing that everyone knows from Hoon, which is the battery payload structure, that'll be coming through streaming, and you might have arm 1, and then we could have our increment arm would be in there. Okay, and because our increment arm is in there, we're going to have to first get it out and then run it against our thing, and that actually gets a little bit annoying, and the only real way to do it, aside from this way we're going to see with a gate, would be some kind of knock 2. So what that would look like would be if we have our core as the subject. It would look something like, yeah, I'll just write it like this. You know, you have your core as the subject, and then you say we're gonna do knock 2, which basically goes ahead first and let's say yanks out our arm, and that will be the sorry, it would go ahead and yank out our variable. Let me back up real quick. Um, it, the issue is we have two things we want to yank at once. Okay, so we want to take from our core, we want to take out, our increment arm. Okay, and then we also want to have some code that from somewhere else. Yeah, and from I got the tar. Um, and then from somewhere else, we want to go ahead and take out the variable to increment. Okay, so this gets a little bit hairy, and it's not too hard to come up with ways to do it, but they're very non-standardized. So what we end up wanting here is exactly a gate, because a gate unifies that variable. We get to make a package that has the formula plus the variable. Okay, and we can put them into one place. So imagine that once if we can say gate equals essentially, you know, you put the formula in the battery and then your sample, gate is form. We'll leave out, of course, gate does have context, but we're going to leave that out for this lesson. The other context. So then what we can do is we can start doing things, and our core is, it has arm 1, but then it also has our gate, um, and all this other stuff. So if we just say that what we want to do is extract gate from core, replace its sample with the variable value, then run the formula. Okay, so it lets us co-locate, like put the sample in a predictable place. And this is like exactly the reason that Hoon gates are the way they are, is because they come from Nock, where this kind of makes the most sense. Basically putting the two things together. So let's look at like, this is going to be really simple, but we'll look at what an actual increment gate looks like. Okay, so first of all, we want to make the arm. Okay, and all the arm has to do for increment is, and I'll show this, and then we'll do some more Socratic stuff later. But we just use a Noc 7 composition. Okay, so what it's going to do is we can set this up here. Inc is this formula. And what this says is, and we'll put it in the context of like a subject that like we have down here. Okay. And all this formula is doing is it says, go ahead and in the current subject, get the thing at memory slot 3, and then increment it. Okay, so that's all it's doing. This is just using Noc 7 for composition. First get memory slot 3, then run increment 401 on the result of that. Why do we do it on memory slot 3, Rapsif? Like this is our like standard gate setup. Why are we doing it on memory slot 3? I'll just let that one hang there for a sec. If you need more time, just paste in there. So what we've done is we haven't made the full gate yet, but we're making an arm that says, okay, so let's just like back up and think what we're trying to do. So to be clear, right now we're making the arm, aka the formula, right? So we have our gate is going to be of the form battery payload. You've seen this a lot in Hoon. And right now we're making the formula for the battery. Okay? And so the formula for the battery says every time you run this, take the current subject, get the thing in memory slot 3, and then increment it. Okay, that's our formula. So let's think real quick about what kind of data structure this implies. This implies that our formula is expecting to run, our formula is expecting to run with a subject that has the variable in slot 3. Interesting. What does that remind? What kind of structure has a variable in slot 3? Let's just think about that real quick. A hint is that it's on this page right here. Because this is going to help us understand a lot about how Nock and to some degree Hoon kind of think of gates. Yeah. Okay. So we have a audio thing coming in. Exactly. It's battery payload, and that tells us that gates run with themselves as the subject. That's like the really big thing right here, right? And we got battery payload coming in right there. Okay, so we now have this thing, and what we're going to do in a lot of this lesson as we build these things is just do a little test to verify it works. So the one here in this thing is kind of a dummy value. It's essentially just putting in the 1 as a placeholder for what our battery could be. And then what we're really testing is that our gate our formula works when it has the, something in the like a 74 in the payload and takes it to 75. So now we're good, and we know that we just have to find something to replace that one. Okay, so now we're going to assemble the whole core, which is the ink gate. And actually, all we have to do, why does it think 3, 4 is in position 3? Okay. I think essentially why you're saying why isn't the form right? Why isn't the formula in position 3? Yeah. So these are two separate questions, but okay, no, it's actually not two separate questions. It's essentially how the formula works. Yeah, if we write it out, and that's actually like the next step. What you'll see if we paste it would actually be 03, right? So you're taking the tails in position 3. The answer is that, and I'm going to write this thing out in like flat form, which ink should do. Yeah, so this is the form like in the simplest one. The answer is, if you look at my screen in the dojo, this thing is closed right here. Okay, we have the bracket at the end, so this thing is a full list. So if we put ink at the head of a list and we put 0 at the tail and we look at it, notice how, and we can actually even take this exact thing, make it the subject, and look at what it says is at position 3 is actually the 0. Okay, the sort of the short answer to your question is that it is like that it matters that this thing is closed off. Yeah, exactly. The O. So we have the aha there, and this is actually not as crazy as you think. If you ever do like a list here and then some number, the list will be in position 2 and the number will be in position 3. It's just like a little, like honestly, just a little bit of bookkeeping. But just assume in general that whenever you have kind of like a cell structure and you put it as the head of a cell, it will just be the head. It doesn't like bleed out into the other parts. Okay. So now we're going to go to basically what we actually did there by accident is we actually went ahead and made the core. So what we're going to do is we're going to call this thing inkgate. It looks like this. We can type it in. And all I'm doing here is I'm saying, when I say put ink in the head and then 0, this is just battery payload. Okay. And if we had a core that had more than one arm, then we would obviously have like a nested structure in the head. But we don't. So we just go ahead and make our one formula there. From what I've seen when I inspect stuff in Hoon in the dojo, that's also how, Hoon ends up making these. They don't like nest that unnecessarily. Okay. So again, we put 0 here. I'm not going to Socratic this one. 0 is just here as our default payload. Okay. We could have chosen any value, sorry, default sample. But we're going to stick with conventions to make things not wacky. I easily could have made it 107 or something, but that's kind of a stupid default. We're really just trying to see where Hoon comes from. So here's like where the rubber really meets the road, and where this like kind of toy example actually is going to teach us a lot, which is how do we invoke it and what conventions does Nock use for invoking a core. Okay, so there's 2 ways that we could kind of invoke this core. One would be if we have our core ink gate. We could put it as the subject, something like this. We could use Nock 2, which basically says use the first formula to set up the thing, and then the second form to set up the subject, and the second formula to set up the call that's made. So 0, 1 would just be keep our gate. Sorry, actually, it wouldn't be 0, 1. We would want to use one that replaces the sample here. Okay, so you could do something like there's I need to look up Noc 10. I should have written that down right here. Okay, I have Noc 10 right here, which is basically we're gonna replace. Let me back up and do it here because I think it's easier. It's easier to see. We're gonna use Noc 10 in a second anyway. To use the default sample of 0, you just call it like this. Okay. So we have 9201, and 9 is pretty straightforward. It has two parts, so it looks like knock 9, B, and then kind of subject setup formula. Okay. So what 9 says is first run the subject setup formula on the subject, and then extract the thing in memory slot B and run that on the subject. So walking, like, let's just like walk through that. If we have inkgate, which is highlighted right here, the first thing we use is the subject setup formula, which is this like 0, 1. So that's just gonna take inkgate and make it the new subject. Okay. So it would just be, our new subject would be the entire thing. Okay. And then it says get the thing in memory slot 2 and run that. Okay, good. Just that's helpful for me if you just say you're tracking. So the thing in memory slot 2 is just our formula right here. So we can actually put it here, run it, and it gives us 1. Basically, it increments the value. What I'm showing you in this line is what 9201 does. So whenever you see a 9 formula, the way you should read it is 2. You almost want to read it backwards. So you ignore the first number, and then you say, okay, what does it do to set up the subject? It just takes the identity of the subject. And then which part of the subject does it extract a formula from to run on that same subject? And in this case, it's the arm2. Okay, so this is for just our, just running a default sample, basically keep it the same, then run the arm2 against it. Obviously, though, what we want to do is we want to be able to replace the sample. Okay, so before we look at that, we have this 9201. What do you think we would have to do differently in order to replace the sample? Which part of this 9201 would have to change? So we're running inkgate as the subject, and our formula was 9201. To repeat, 1 gives us all of inkgate. 2 says look at position 2 to find the arm, which refers to yes, just with one modification. So 1 gives us all of inkgate, exactly. 2 says find the formula, the arm in position 2. Good, so we yank that whole thing out. And then what it does is it says run that against like the thing that we got in the first step. So essentially the first step generates our subject. Okay, the second step gets in arm from 1, and then the third step runs that arm against 1 again. So essentially we run 2 operations against 1. We run an arm extraction operation, and then with that formula that we get out, we run it against 1 again. Okay, so yes, internal inkgate is referenced with 3 ifs, which itself is 0. Exactly, you're exactly correct. Okay, so what you want to think of is we're doing like a double run against inkgate. In order to use a sample that's not the default, I'll spoil it, and then let's think of how you would do that. We need to set up a different subject in step 1 so that we still get the same arm, but that it has a different payload when it runs that arm against 1. Okay, so instead of 0, and you can just tell me in pseudocode or what you want it to do, and then we'll see how to do it. But what should this formula do instead of just taking inkgate? What do we need our formula to do? And if it takes a while to post through here, you can, audio me. This is really a HIDEV thing. The rest of the ships are actually super fast right now. Like all my stuff is like blazing these days. Exactly correct. Extremely clearly stated. We have to use the Nock formula to replace the 3 position. Okay, so there is a Nock formula that's perfect for that, which is Noc 10. I want to actually go back to some replace. Yeah, exactly. So we have to go ahead now, and what I'm going to do here is I'm going to set up a little bit of a different, a different thing at the start because I'm going to imagine that we were calling that we're essentially like calling inkgate. Um, so the setup I'm going to do here is we're going to assume that our kind of call thing is to make the subject be inkgate with our parameter as the second value. And what we want to go ahead and do then is we're going to need to knock out the sample in inkgate and replace it with this thing in position 3. Okay, so that's Noc 10. Noc 10 is perfect for this, and what Noc 10 says is um, it's a little easier to read back to front. So this one it goes as, I'll just write it in here like the way it is. So it goes 10 B C um, and D. Okay, so it's 10 B like B C D. And the way that goes is C is a formula to get a value. D is the structure that we're going to replace something in. Okay. And B is the position in D to replace. So, just to give a concrete example, what this is saying is our C is 0, 3. So that's our value, 36. Now our old 3 is in position 5. Um, Actually, our old if we look at the thing that if we look at like what results here in this thing when we run 10, our old 3 gets totally replaced. Okay, so this is actually a thing with Noc 10, and I what I did right here is I isolated how Noc 10 works and didn't do it as a function call. So what we do here is our C is to kind of get the value. That's 3603. Our D is inkgate, okay? And then what this says is replace slot 3B in inkgate with this value, 36. And so actually, if you look at this thing I have highlighted here, it's exactly the same as what we ended up with for inkgate. It just has the sample knocked out and replaced. So I'm just highlighting first that one right here in assembling the core, and then highlighting this right here. This like Noc 10 formula, all it did is it surgically went in and replaced that. 36 goes into the slot where mem is currently 0. Yeah, exactly. Noc 10 is one of those things that is a little hard to follow because you have to kind of read it a little bit backwards, but it is extremely useful. So each time you need it, it's kind of worth. Actually, this is actually kind of a very practical recommendation. What I'll do is I'll make a simple expression like this that just isolates the Noc 10 and kind of makes sure it's doing the right thing. Okay, so practical advice here is you can really do a lot with these isolated sub expressions, and it's a form of like on the fly testing. Okay. So now that we kind of trust that our Noc 10 formula can go in and knock out the sample of if we have like a cell with our gate and then a variable, we can go ahead and use 9. So remember 9 is it has this one right here, which is going to be the arm we call. But first it has the subject setup formula. So our subject setup formula, which is highlighted, is exactly the same as the subject setup formula that we just tested, which we know will take this subject of inkgate 36 and just return ink, and it will just return inkgate with 36 in the sample. Okay, so it's going to go ahead and do that first. Then, because it's Noc 9, it takes the arm out of it, which is we can actually just see right here what that'll be. That'll be the thing in slot 2. Yes. One is fungible for some other Noc that sets up a subject. Yeah. Okay. So when we were looking at 9201, the way you always that 9 will always be is that the first two things are numbers. It will always be 9 and then some memory slot and then subject alteration formula or I think subject setup formula is the clearest way to say it. And so in the first one, our subject setup formula was just 0, 1. We're just saying, give us the thing. without making any modifications. So we'll run the default sample. And in this case, we're saying we want our subject setup formula to be this one that knocks out the sample and replaces it with the value that's in position 3 right here. Let me just grab some water. That's a good. So okay, so the way I figure, the way I, or well, sorry, can you clarify the question in chat? Are you asking how I figured out how Noc 10 works, or how I figured out to like make gates in this way? Because I think it's actually the answer is actually kind of interesting. Yeah, so the way I figured it out is first by banging my head at Noc 9 and just kind of looking at it a lot. And what I tried to do was like once I like kind of broke down the formula like I did in the last lesson, I really tried to figure out the intuition of why someone would make this like opcode in the first place. Okay, so I think I really try to reverse engineer everything from why is this here? Because Nock is such a tight, tiny language that everything's there for a reason, right? So if I see, for example, Nock 7, and I'm wondering why is it there, it's because it lets us express this idea of composition really cleanly, where we can read this as get the thing in slot 3 and then immediately run this formula on it. Okay, so once I have that, I kind of put it in a hook in my mind for composition, just because that's such a like common operation to come up in program, like just in programming in general. Similarly, like Noc 8 is like put another variable in the head. And Noc 9 was weird for me. Okay, so the way I got Noc 9 was when I realized this thing that I wrote up here that I'm going to highlight, which was that it was all about doing one first setup step and then running two completely different steps, both against that subject. Okay, so the key intuition for Noc 9 that kind of makes everything super clear is that we're doing this subject setup formula in order to first extract an arm from it and then run that arm against it. Okay? Just tell me if you're tracking here, because this intuition is really important for the rest of the lesson. Yeah, you're saying the hard part transitioning from who is that we're holding in mind these subjects. Yeah, I mean, look, there is some like mental. So what I agree that it's hard to keep it all in your head, and my head isn't particularly better at this. I mean, I'm not horrible at it, but not amazing. I think it's more that once you have the intuition really locked in, like it's hard for me to just eyeball 9, 2, 10, 3, 0, 3 and see exactly what's happening. But once you have the intuition for 9 really locked in, you at least have like this mental hook where you can kind of start manipulating the other things. Like you can kind of hold that in place. So even if I kind of keep forgetting what's going on, I'll keep saying, I'll just be able to keep coming back to, okay, I'm trying to set up a formula so that I can run two separate operations against it. That's really the key thing for Noc 9. Noc 9 set up a subject in order to run two separate operations against it. Okay? That's like really the key thing. Two separate operations. So in this case, going back to our practical example, the two separate operations are, so we set up the subject like that we made right here, which is ink gate with the sample knocked out. And then we run two separate operations. First, get the formula, and then run the formula. But they're both happening to that new subject that we make. Okay? So just let me know if you're tracking here, because if you kind of have that in mind, what you can do is you can kind of free your mind up. If you had two gates for subject 9, 3, yeah, definitely. So this is a great question. This is exactly how you want to think of like Noc 9. In fact, I don't know if I do this in this lesson. I have to check, but I think I do. This is exactly the case of a core with multiple arms, right? When you say 9, 3 setup formula. In fact, it wouldn't usually be 9-3. It almost always will look like 9-4 or 9-5, and that's just because if we have this structure like arm 1, arm 2, and then sample, for example, this is a door. This is a door right here. Um, if you have arm 1, arm 2 sample, arm 1 is in slot 4 and arm 1 is in slot 5. Yeah, 9 is going to be like the value is the sample is going to be in 3, right? But you're absolutely correct that you very easily might want to do something like 9-5 on a thing that sets. Let's let's imagine that we were just leaving our sample the same because that's like the easiest like trivial case. We could easily imagine something like this for Nock that would look like so this would essentially be running a door, an arm of a door with a default sample. I'm live coding, so I have to check the syntax, but notice what we do here is we would be saying, okay, our subject setup is just take the whole thing, and then we run arm 2 against it, and presumably arm 2 would use the sample in some way, or maybe it would even also call arm 1 against the sample, further using Noc 9 potentially, something like that. But Noc 9, the motivation is that you can set up gates and doors and cores exactly how you want and then knock them down. Okay, so let's go back to our example here because it looks super complicated, but it's actually not that bad. This entire thing here, which we just tested right up here, is just knock out the sample with the second value that's passed, right? The tail of the cell. So we go ahead and do that, and that essentially gives us a gate. We say get me arm 2, the arm in 2, and then run that against the same gate, which increments it. Okay, and then we just show that we sort of have a fully general thing for that by putting 562 here. Noc 10 is, I don't want to go too crazy with it. It's one of those things where you just have to kind of look up the source and do it. There's other ways you could write this, but this person is confusing is the 303 code because 36 is 3. Oh, yeah. That's one where I would say I wish I had set up the example better, but it's just like one of those things in life that's gonna come up a lot, which is, position 3 is a very important position in Nock and in Hoon, because it's like the tail. It's the tail. So there definitely are 2-3 positions. So key thing here is that these are two completely separate operations, which is, or even like this thing here. This one is extracting the value 36, and then this 3 is replacing a sample. I think that's the most concise way to say it. In our code here, this is the formula for getting a value. This is the formula for setting up our thing we're going to edit. And then 3 is the slot to edit in. So it just, whenever you're replacing it, if you're replacing a sample with the tail of the subject, you're going to have the 3. Yes, exactly. And this is one thing where it's unfortunately had like a month between lessons, but opcode 10 is basically, the way to think of it is slot value, I can write it more clearly, slot value formula. I know. So I don't want to make it seem like this is inaccessible because I know it feels wild, but the way I arrived at this when I was making it is, in my head, I was like, damn, I really wish I had a way to knock out the sample and replace it with something else. And, there are a lot of kind of convoluted ways you could do that. And then I was like, oh, wait, I have Noc 10. Why don't I just use that to knock out the sample? And then everything else was just kind of sitting with the documentation for Noc 10. And that 3-3 thing confused me as well. And I just kind of had to think about it a bit. But what I really try to do is like replace these things with intuitive concepts rather than just variable names like ABC. So actually, you know what? There's even a better way to say this that I'm going to put in here, which is target slot. Okay, So let's like exactly track this to our thing up here. 3 is the target slot. 0.3 is the value formula, so that gets us the 36. 0.2 gets us the subject to edit, which is inkgate, and then we replace target slot 3 and inkgate, the sample, with our new value 36. Okay, and just give me a affirmative if you're tracking it. But the key thing is that oh 503. I see. Yeah, that makes a lot of sense, and it just doesn't happen to be 503 because we actually extract the whole ink gate with 0.2, and so it's sitting there. Okay, so now we have it. We just have this ink gate, and we can kind of use it however we want, and it usually turns out to be a good idea to use it in this like pattern of use knock 9, knock out part of the gate or the door, and then choose which arm in it you want to call. Okay, so I had in my summary like, okay, what was the point of this? We took a perfectly good increment formula and made it more complicated. um, but the answer is that it makes a clean environment. It basically co-locates the formula with the data so that it's really easy to run knock 9 on it. Essentially knock 9 can just say go get this chunk and knock out the sample. Okay. So I don't think I really have to justify that at this point, like what the win is. We found like a very generalizable way to use a combination of knock 9 and 10. And by the way, when I was talking to Ravnis the other day about just various parts of I think Arvo, that's an idiom that like comes up a lot, like just knocking out something, usually with knock 10. Okay, now we're going to make a decrement gate. This is going to be a lot faster, actually, even though the code is more complicated. So what we're going to do is we're going to take the decrement formula from the official Nock tutorial example. And after this lesson, you probably could build it yourself. Even though it looks long, it composes out of a lot of pieces. So I made some modifications to it so that it crashes on invalid values. So let's just take this thing right here. And for where we are right now in the lesson, you absolutely don't have to follow exactly what the code is doing. Although it starts off with a Noc 6, which is an if else. So yeah, what the hell? I'll show the error checking code right here because I think that's cool. Noc 6 is an if else, so it has a condition, and then that conditionally like evaluates either the second, the first or the second formula after. So all it's checking is we extract the subject and we check whether it's equal to 0. This is just knock 1 to give us the constant 0. Okay, so if it's 0, then it does this thing 0 0, which I'll just show you what that does. If we do the formula 0 0, it crashes. Okay, so basically it's saying if the subject is 0, go ahead and crash. If not, run this next thing. Okay, which is another if. This checks if it's a this checks if the thing is a cell. Okay, and so this one just says if it's a cell, if the subject is a cell, then crash. Otherwise, run the rest of our code. So actually, our decrement code is only this stuff at the very end. And this first part is just very easy to understand error checking. And to be honest, whenever you see a string of 6s and 5s, you should you're looking at like kind of sanity checks or like cleaning the data. Okay, so this looks kind of hard, but it's actually super straightforward to parse. In terms of testing it in the dojo, we can just look at it and just make sure that it works, which is we'll run that with deck, gives us 99. And then if we pass a cell, it crashes. And, as we also can guess, if we pass 0, it crashes. Okay. So now we need to go ahead and make this thing into a gate, which means we need to get the arm ready for battery payload. So this one will go faster because it's exactly the same process. We have what happens if you don't have error checking? Yeah, it's actually not a dumb question because I did exactly this when I was messing around and seeing what would happen. And the answer is that the way this code is implemented in their example, it goes into an infinite loop and you have to interrupt it in the dojo. So actually not a dumb question at all, and I had exactly the same thing. Same if you pass a cell, it goes into an infinite loop. Um, so again, we get to do the same thing where most arms of gate. If you're doing a gate, which is just like one arm, it's always going to be super simple, which is basically use Noc 7 to get the value out of the sample and then go ahead and run your formula on it. Okay, that's always going to be your arm, and the gate is very, very often just going to be a really simple Noc 7. Go get the sample, do stuff to it. Essentially, just set stuff up in the way that decrement expects, okay, or increment expected in our last one. And I just do some sanity check code here to make sure that it's decrementing the value in the tail. So I like to do this thing where I set up a dummy subject, or like a dummy core, where the first thing is just a number that never gets used, and I'm just testing it against the sample. Okay, so just notice this is a really easy way to test. Is you can always test gates by taking the arm code and just running them against a dummy core where the sample is real, but the battery is not. Okay, and then the full deck arm code is, so we had made the deck arm face right here. I'm just gonna put it in here. By the way, it formats it. So I formatted it in this way just to be legit, but it actually goes ahead if you type it in the dojo and formats it in this form. Okay. Interestingly, do you notice before we go further, do you notice anything at the near the end of this deck arm code? Or in fact, if we go back up to the top, there's our 9201. So what does that tell us is probably happening in the in the decrement code itself, like this thing that we're taking for granted? What does that tell us is kind of part of its algorithm? What does 9201 mean you're seeing? Yeah, it's like a door. In fact, what 9201 has to mean is that we don't even need to replace the sample. Okay. So what it means is that we're good with just running. We have some core because probably there's some looping going on, and we're good just running it as is because it knows how to get all everything is in exactly the places that it expects. Which actually makes a lot of sense because this decrement code is done to run against, as we saw up here, to run just against a number, right? It's not expecting a gate or anything special like that. And that's why it's kind of predictable that it will just end up doing 9201. So now we have the arm, and now we just make it into a core. It's a complete gate. It's expecting you to call it with some. Yeah, well, actually, so tell what or rep stuff. We can make it a little bit more precise. It's not that it's not a so sure it isn't a complete gate. Yeah, it isn't a complete gate argument combo. It's like a chunk of code that runs against a number, as opposed to our gate is like this, the complete thing with the sample that expects you to knock out the sample and then and then run the arm against itself. That's basically the difference. So again, to make a gate is usually really easy. You just put your arm and then you put a default value for whatever the type is. And in this case, it's a number, so we do 0, and that gives us deck gate, which is our gate. And we could kind of go through the whole rigmarole again, where we do. Well, actually, I take that back. For deck gate, we actually can't just call 9201 on it. And why is that? I mean, I can run it if we want. Yeah, in the infinite loop, or because I put in error checking code, it will crash. But so yeah, if we put deck gate and then try to run 9201, the default value is of an integer is kind of invalid for it, so it does it. Okay, So that's why I don't have any example of it. But again, I go ahead and decide my calling format is going to be this like kind of gate and then argument thing, just because it kind of looks like a function call, like deck gate and 36. So I just want to make sure I can knock out the sample. So again, it's this exact same code of that we extract the value 36. We get our, what do I call this? The subject to edit is deck gate 2. And then our target slot is 3. So we put 36 into the target slot in there. And notice this is all our deck gate code, our deck arm, and now with 36 there. So we just tested and we made sure our 10 code works. So now we know that if we run this with the same subject, it'll produce this whole thing. So now we just do a 9-2, calling the arm in 2 with essentially our editing code, which we already tested against the exact same subject, so we know it will work perfectly, and it works. Any questions at this point? So notice that aside from being long, there's no differentiate which two a bit more. Oh, you want me to differentiate the one where I test versus 9-2, I think? Just give me. Yeah, okay. It's really simple. This one is a Noc 10 formula right here, which essentially returns the gate itself with the sample replaced. This one is a 9 formula that's going to call arm2, right? So I think the key thing to understand is this thing is a sanity check or a test. And what I love in Nock is that you can very often, and we'll do this to the rest of the thing, kind of set up these little tests once you've built your code from the ground up. So we, in fact, started by having code we thought worked with deck. We tested that. Then we built that up into like a deck arm, and we tested that with like a dummy core that only had a sample and like a kind of a dummy battery. And then we went ahead and tested our edit code against the gate to make sure it correctly knocked out the sample. And only then did we go ahead and run our real thing. And now we have we can just run this whole thing and just replace this value with whatever we want, and we have decrement going on. Any questions on there? um, I don't believe a human invented this. So keep in mind that there's no reason that like all of this stuff is like it's like those whatever like the game of life where like arbitrarily complex things emerge from like really simple rules. And all I'm doing is kind of saying, oh, I want to edit a subject. Oh, I want to like call an arm, like extract an arm, and then call it against that subject. You know, oh, I want to add error checking code. And honestly, it's just the fact that everything is in numbers that it builds up. Like they easily could have written 7 as compose, and then our like thing right here would just look like compose slot. I'm taking this thing right here, just to be clear. It would look like compose take slot 3 if um equals, and this would be very valid, slot 1 to constant like 0, right? This is like the highlighted code here and the thing I'm typing in chat. Those are exactly the same. I'm going to move this up a little bit because I just remembered. Yeah. I'll move this up too. Oh, crap. Sorry. Going down. Okay. But notice that this looks a lot more kind of human readable. Yeah, and there's absolutely no reason, 0 reason at all, that Nock could not use words like this. The reason that it doesn't is that, and I was working with Robness a little bit on a document, like kind of explaining Urbit in an hour. What it lets them do is unify code and data. So they have this abstraction that, you have all that there are nouns, which are just like atoms or cells, and atoms are numbers. and it just lets us represent code using that unified data structure that's as simple as possible, and kind of throw it around and have everything use the same types at the bottom for simplicity. Okay, but it's very instructive to see how I'm not gonna like pretend that when I look at this, I just see words and not numbers, but definitely I do see some patterns. So if I see, to be honest, if I go up here and I see something like 6 5, that looks like if equals to me, and you do start to kind of pattern match some of that stuff. Um, the way you can use, yes. Essentially, you're asking how does it know whether it's a number, or not, and it's completely because of position. So essentially, each knock opcode assigns semantic value to positions. Okay, so if we have knock 9, the second thing must be a number. Okay, it has, or an atom. Like it has to be a number, and this thing has to be a formula, aka a cell. Okay, so 9 expects atom cell, and the atom further is going to have to be a memory address that works once we get it. Okay, and again, this 9 only has meaning because it's the first thing in the cell, and because we're evaluating it. So if I have 92001, actually, let's do this in the dojo. Yeah, exactly. Memory just 9, not 9 function, and that's completely from the thing. So to be honest, I could do write 9201 here, and that's completely inert. Okay, because Nock never evaluates the subject unless there's something in the formula that does that, right? So if I just do 01 or something, it's just going to give me that again and not do anything with it. Okay, so and similarly, 9201, if I have like, I don't know, like what I could write 40, wait, is this gonna, yeah, that actually works. um uh, uh, Again, the 4 only has this meaning here because it's right, like because it's right here. And the reason, I think the thing that's confusing you, or that can be confusing at least for me, was that um essentially the question is, why does this 0 end up getting evaluated as a memory slot even though it's in the middle? And that's just because the definition of knock 4 is for formula. Okay, so that tells us that we're going to be evaluating that thing in that way. Same with like knock 10, which we already typed out before. It actually is target slot. It expects a cell right here where the head will be target slot, which is a number. The tail will be a formula, aka a cell that's valid as a formula, and then this will be subject to edit. Sorry, it really should say formula for subject to edit. So again, it's expecting a cell. And yeah, no, that formula. Yeah, I mean, dude, we haven't done this in like a month or something like that. Like it's, I took a refresher before I like got online for this one today. Yeah, the semantic nature of each knock formula is static, and if you get it, it just sticks. Yeah, that's basically what it is. You might have to reanalyze it every so often, but if in your mind you have these hooks like, oh, knock 7 is composition, let's figure out what I'm composing here and kind of break it down. Or, okay, it's knock 9, it has to be doing these things. Usually, what I'll do is for each one, there's kind of a thing I'm targeting. So for knock 9, I'm trying to figure out what type of subject they're setting up. For knock 7, I'm trying to figure out what the two formulas are. For knock 6, I'm trying to look at what the if condition is, like, or sorry, what the equality condition is. They all have like kind of their own thing that you first look for. Knock 10, you just cry because it looks really ugly and is weird. But once you stop crying, usually I'll look for, okay, what's the kind of subject we're going to edit? What's the value? What's the target slot? All right. Yeah, if you once you see through the tears to clarity, that's a pretty good summary of the process. Though that each one is static, and you can kind of look at it like that. And there's also very clear expansion rules. Of course, I prefer reading Hoon to like to Nock, but I do sometimes miss in Hoon how small the surface area of Nock is. Okay. let's look now at, we're going to make a program that compares two numbers. Okay. And so this one, our final output that we want, and this is pretty common, we're going to want to take a subject that has two numbers, A, B as input. If they're equal, return 0. If A is greater than B, return 1. If A is less than B, return 2, meaning that if I had 2 and like 101, yeah, that's a really good question. I think for the stuff I'm working on, probably not. I just like, there's a except for the fact, and this is a real thing, there's like a real value to kind of like knowing what's under your feet there. And so for me, and this might just be the way my memory works or my understanding works, I understand things better when there's more hooks to hang things on. And so for me, if I have like a hook of a door, if I kind of have this feeling of what a door is really doing under the hood, it makes it easier for me to grok doors on the fly and kind of deal with them in various edge cases. Same for handling stuff like, our battery payload and breaking that down. It's a lot easier for me to break, like kind of hold it in my head and break it down and feel confident about it if I know what's happening under there and there's like a real thing. Like this is a trivial example, but just the fact that I know that like battery either is going to have the structure arm, just one arm in the head, or is going to have the structure arm, like one arm two, and then other stuff. And that's really what's there underneath. I feel like I'm kind of walking on solid ground, and I feel a lot more kind of confident as I go and manipulate things like little lark expressions or analyze, especially analyzing other people's code. It's really helpful for that. Um, and maybe it's just a confidence thing that like some people can kind of take it on faith. Uh, like I don't want to get into like religious debates or anything about it, but it probably indicates even how I view things like religion, like aspects of it, where maybe there is like a thing where people can just like really trust it. Yeah, Hoon is an abbreviation of Nock. Um, yeah, I want to do like faith learning practices. What were those like George Bush type things, like faith based charities or something? I want to bring that back in this context. We should think of oh, yeah, I think of Hoon as a layer on top of Nock that translates directly, and it's also really helpful if you're thinking like why is Hoon weird in these ways, to know that it's weird. Yes, the IRS does not like your form of learning. Okay, let me go through here because this is probably like bad radio for people who end up watching this later. Um, so we have this thing that we want to do, which is we want to be able to say I have the number 3, the number 101. I want to run. Oh, sorry. Right, this is my subject, and I want to run my comparison formula and have it return, in this case, 2 because A is less than B. If they were equal, I would want it to return 3 at the end of the day, and then similarly 1 if we had 101 3. Okay, so that's what we're kind of going for. So the only mathematical operators we have to do this with are the 4-op code for increment, 5 for equality, and we'll use the decrement function from earlier, the gate that we made. So the algorithm is actually pretty simple. We'll just take a second and look at it. And if someone was going for this, they could do it as an exercise, but I'll just say it here, which is if our numbers are equal, we can just return 0. We have an equality operator. If A is 0, return 2 because we know A is less than B. Because if B was also 0, we would have returned in the first step. So if A is 0, it must mean that B is not, because we got past that first step, so we can return 2. Similarly, if we get through the second step and B is 0, we know A cannot be 0, and so we return 1. Exactly, it's a race to the bottom. Yep. So we first just check and make sure they're not equal, and then we do a race to the bottom. Your thing is way better than mine. So implementation plan. We want to construct a core that has 2 arms. Okay. So one arm is going to have like that algorithm, and the second has the decrement gate from example two, because the arm with the algorithm logic needs to be able to call out to the decrement gate, which is this is exactly the same as if you're putting it in Hoon terms. Um, this would feel a lot like I think like Barket, where I have to check. Honestly, it might be just closer to like bar hep, but basically you have one thing of logic and then an arm that it can that it can refer to. This is like pretty similar to Barket. Um, so our final core is going to have the structure battery payload because it's a core, which will be, and the final core will have our main logic, our decrement gate, and then we're just going to put those values A and B in the sample because we're going to need to have a predictable place to find them on each run through. We've already seen, how that's useful. So essentially, we're going to do that equality check first, and then if it fails, we'll set up this core with A and B in the sample. Okay. And that'll turn out to be really useful to know exactly where they are. What it'll let us do is our main logic can go ahead and extract them from the sample and then put them into the sample for dec gate. Okay. So first, we're gonna kind of build this thing inside out. We're gonna build the recur code and then put it into the if else tests, which I don't think I have to justify that super hard. So the recur logic. We're going to assume that the decrement gate lives in slot 05, the tail of the battery. Okay. Um, and then and this part gets a little bit complicated, but basically what we want to do is have code that can extract the decrement gate and also knock out the appropriate slot in it. Okay. So if we remember 10, just a quick refresher, 3 is our target slot. This formula, it gets our value. Cat what call is 0 1? Yeah, this actually looks good. Else deck arm with recursion. Yeah, no, that's exactly right. Yeah, we're basically writing this in Hoon, and then we'll have like the deck arm below it. So that now, if we compare this to what we end up with the final code at the end here, like it definitely is longer in Nock, and that's why it's written there. But that's like the exact pseudocode, and it's actually going to be kind of cool, I think, for you to see how closely it maps, especially deck arm with recursion. So what I'm looking at here is basically setting up the deck call. Okay, so what we do is we do an edit to extract the gate and knock out the appropriate, put the appropriate sample in. Okay. And then we're going to invoke it with 9.2. So first of all, we actually still have deck gate saved here. Yeah, okay. So we still have deck gate there. So if we look at this code here, we have deck A and deck B. Okay. And remember how we said we're going to set up a thing where A and B are our sample? Totally, exactly what we would expect. I think even in your setup right there. So what we go ahead here and do is deck A, and they're in possession 6 and 7. Yeah, in fact, I think it's actually really easy to see what's happening. This is actually easier to understand Nock 10 here because it puts them side by side. And so this one is just saying grab the 6 sample and grab the 7 sample. Our target structure is the deck gate located in 05, and just knock out its sample 3. Just tell me if you're tracking here. But honestly, at this point, this should be pretty straightforward. The question I'll ask here is, what is deck A intended to be called against? Yeah, it's the kerning does mess it up. Well, that's like, oh, I see. It's really just from That's crazy. It's happening right here. And these are like, this is exactly the same text. If I was like more autistic, this would like make me really angry. Um, so what I want to say here is, what is the intended subject for this formula? I think it's pretty clear, kind of pseudocode wise, what it's doing. What is the intended subject there? And a hint is that when you think of Noc 10, you can think of like this last formula as the thing it's targeting. Right, that it's so what's the intended subject? This is a formula. And in fact, I'm just going to take dec. Yeah, exactly. Main logic, decade. And now I think you're getting to the point where the stuff starts to kind of all fit together and flow a lot more easily. So you're just like, oh yeah, I'm just calling, we're setting up this whole core. And then at some point during the core, we always have the option of calling this. So it's kind of this cool pattern where and this is really similar to Hoon, but at any point during the core, you can kind of go ahead and make a call against an arm in the core in a predictable way. So those Deck A and Deck B both allow us to do that. I'll put it in here so we can follow it along. And then I go ahead and test it. You may have looked already at the thing, but how would you go ahead and test it like Deck B? So meaning that I want to have some subject and let's say Deck B and test it. What should subject be here in order to test it to kind of get that? You wrote the exact structure, so what would be like a reasonable. And you can let me know verbally or in chat, but what would be, you even wrote out kind of the structure we're running it against. So what would be kind of a sane like test value here to make sure it's doing what we want? It says you're talking. Oh, but I didn't hear anything. Oh, yeah, exactly. Actually, no, no, no. With position five, no, because position five is the decrement gate. So So think a little bit because like you actually are exactly right. So position five, we're going to be extracting like this is we essentially we want to. You said this was the subject, so we want to make a dummy structure that kind of replicates this. Exactly. And then what should we put as our like let's say dummy? We can do a dummy main logic. Exactly. And again, just to be clear, the one could be literally anything. One deck gate, and then this could also be a dummy if we wanted because we're testing B, but we can just put both values, but like 6 and 10, and we're expecting this to go to 9, and it does. Okay. So the reason I like to do this is to kind of like reinforce for myself the structure overall and what's happening because in Nock this is kind of like important. And it can get a little bit confusing, but the thing you can kind of take as firm, solid ground is that we're targeting this core as our final product to run everything against, and so we can just keep extracting stuff from that core. Both code, we can keep extracting code and data from that core. So here we extract data from it. Here we extract a formula, and then we use our various bookkeeping in order to run it. Yeah, it's really cool. This was a honestly, the first time I did Nock, when I got stuff working and wrote the first parts of this tutorial, I did not understand this. And then I was setting this tutorial up and I wasn't satisfied with how I was kind of using code and organizing it. And it actually took me a while. I had to walk around for a couple hours in the park and play with it in my head. And then I realized that this was like very predictable and repeatable, and you were just doing the same thing over again, over and over again, getting a bundle of code and just extracting arbitrary code and data from it, and running them how you want. And so what that necessitated that I hadn't been doing before was making my arms be gates. Once my arms were always gates, it was really like the once the essentially the data and the formulas were kind of co-located and you could just knock out samples, then everything worked. And that was a big aha moment for, okay, why does Hoon do gates? It made a lot of, and, by extension, then doors, etc. It made a lot of sense because it's targeting this structure, and it's just a very thin layer over Nock, very very thin. Um, so this actually might go pretty fast now. So notice that we make our, what I do here is I make a dummy core. I put like a 0, 1 in deck gate, could be anything, and then put the numbers and test it with deck A, deck B. This is probably better than what I did in the dojo. Okay, then the recur formula is going to be replace payload with new A and B and run the current core. So what this one is saying, we can already see, and this is what I was saying when I kind of eyeball a 9 in a Nock 9. I'm trying to figure out what's going on. I'm like, okay, this is taking the first arm out of 2, right, with the 4. So basically, we know that's going to happen. So then I ask, okay, what subject are they setting up first? And so this is kind of nice right here. What subject is it setting up? So essentially saying 9, run from 2, the subject 10, the formula. Yes, deck A or deck 2, the subject 10, the formula with the 0 replaced, which is now yes. And when you're saying this, you're looking at the 9, 2, 10. Yeah, let me I always read these, depending how I read them depends on the opcode. I try to read 9s kind of back to front. First, I look for the formula and see what it's doing. So basically, I'm looking at it, and once we kind of figure it out, we're like, oh, it's getting the thing in slot 5. It's replacing the sample of the first part of the sample of that. The sample of that with whatever's in 6, and then running. The recur formula is a little bit, again, I start kind of at the end to see what kind of subject it's setting up. And this one is pretty straightforward, which is just get the battery. So one thing I want to emphasize that it's completely opcode dependent. Okay. So if you see like something like 403 or this, actually, is that true? It is okay. So when I see a 6 opcode, I read it left to right. Okay, so I read it as 6 condition arm 1 arm 2, or you could even call it like true arm. No, sorry, that's not even arms. True formula, false formula. So I read this left to right. I'm like, if this is true, run this. Otherwise, run this. So I do read that one like that. Whereas 9, because it's like, arm slot and then subject setup formula, I just always end up wanting to know like what the subject setup formula is doing, because otherwise arm slot is meaningless. Okay, so like for example here, if I'm like it's gonna get a 4, yeah, I mean I kind of know what that is, but it actually depends a lot on what this thing is doing. Like in this one, we run a 2, but it's only because we actually go and extract the gate first and replace its sample as part of our subject setup. So the easy way of saying that is like the order of reading is opcode dependent. And this is where there is like a little bit of an experience thing with having read the opcodes a lot, where once you have the intuition of what the opcode's doing, you know what's happening. 7, by the way, I totally read left to right. It's like get this data, like process it with this. Okay? So like 7 is like totally left to right. It really just depends on them, and you just have to kind of have an intuition for that particular opcode. We see 9 so much that I just force myself to read it this direction. So here we see the formula is go and get the battery 2. then run formula. We actually have kind of three formulas here. So this is kind of interesting. Remember from our very, very first Nock lesson, part one, we talked about like the cell maker formula. This is a cell maker. This is our whole formula, and it consists of three discrete cells, right? 0, 2, this deck A thing, which is a cell, and deck B, which is a cell. So that means the final output is going to be, the result of running deck A on the subject, because it's going to go ahead and run it on the subject, and the result of running deck B. Okay? So the key thing I want to say here is we have 0, 2 formula, which can be read as battery formula, or even formula result. Thanks. Let me know if this is tracking, because like this is really critical and makes it. It goes from like kind of annoying to understand to very easy once you realize that like these are both formulas, so they're going to produce results. And this is really cool because deck A and deck B also both just we've tested them and we know they can just run against our core and produce numbers. Okay, so just get yeah. Let's get to that. Let's. Are you tracking up to there in terms of what we set up here, which is that we okay, so just to recap it, what it's doing is it's a cell maker, so it's going to create a cell with like these three different, these three consecutive entries. The first one is just getting the battery, like our entire battery, both the decrement gate and the main logic. The second one is just running deck A on the current subject. So this is why I read it back to front, because up until now, this 9-4 is totally irrelevant. Okay, this entire formula runs against the current subject at the start of this with no regard to 9-4. Okay, so 0, 2 is our battery, deck A decrements A, and we know that as long as the core has the right format, it'll do that, and deck B returns B decremented as long as the core is in the right format. Okay, so with that, we know we are going to end up with something that looks like battery, and let's just give fake numbers. Like let's pretend that we started with like 730. It'll return 629. Now it then says extract ARM4 from this battery 629 thing. So what is ARM4 there? Yep, main logic. Okay. So then it goes ahead and extracts the main logic and runs it against battery 629. Battery 629 is is our core in the first place. So now we're just running against our main core, but with both values decremented, aka recursion. Yeah. The key step is for our analysis of the code is that we can analyze this completely separately from the 9-4, and all our job is to do here is to recreate our like original core with decremented values. Okay, and I think I don't even know what the justification is. Like in some ways beauty is its own justification, but this is pretty beautiful and validates a lot of what Nock and Hoon do in terms of setting up the difference between a battery with formulas and a payload with data, right? Because all we have to do is keep our formulas exactly the same by using 0, 2, and then we can do what totally new things with the data and just run it again. Okay, so as long as we end up having at the top some if logic to check for whether A or B is now 0, we'll be totally good. So we can go ahead and test it. I'm just going to put my recur here and just make sure that it is like real code. That's what it looks like. It's actually not super long. If you kind of look at it, you can actually see the deck A and deck B. Yeah, I agree that recur is incomplete without a dummy core. So it's really helpful to build this thing up from the ground up. because it turns out that I think there's an important insight here, and I want to like extract it fully. Yeah, it's like calling yes, it's like calling a gate and getting the arm hashes. Essentially, you can when you're doing dummy core, you're basically treating the formulas you haven't written as arm hashes or like placeholders. Is that helpful? Because you're on to like a very important insight, and the insight you're on to is why is it useful to separate like payload? Okay, it's useful. I'll say it one more time. It's useful to separate battery from payload because what it lets us do. So separating the two lets us think about and work on battery incrementally. Okay. So basically, we can take the parts of battery, the smallest parts of battery that manipulate payload, and make sure that they work while using a dummy core, and then build up from there. So what we did here is our battery consists of main logic and deck gate. So we actually just spent the first part of the lesson just we're like, all right, get me a deck gate, right? We're like, okay, I know I'm going to need this. Get me a deck gate. And so we just totally put everything else aside. We don't have to hold anything in our head. We know what our spec is that we want, which is a working deck gate. And so we go ahead and make that. Then we come back here and we're like, okay, now I want to make sure that deck gate manipulates the payload correctly. And because the payload is separate from the battery, we can actually like just put in deck gate into our dummy core and then make sure, that it works. So it lets us treat everything like a little bit at a time. So you're correct to kind of be uncomfortable that we have this big blank spot where main logic should be, but we're able to build it up incrementally from the bottom up by just saying what's the smallest thing that we could build right now. And I want to actually show how we can go ahead and test that. What we're gonna do, it racks. Just like the hot version of tracks. Okay, so if we have like we can actually go ahead here. And what we're gonna do is we're gonna use our same dummy core. I'm even gonna simplify it a little bit just because I think it's easier just to put like a one as the placeholder. So we have our dummy core right there. We're gonna go ahead and run the recur logic on it, and the recur logic. Notice all it does is create a new core using deck A and deck B, but it doesn't actually run the main logic. So it's kind of like create like we're just checking like do we kind of get a totally inert core back at the end. And I actually want to break down what this like gives. Hmm? Okay, wait. Oh, wait, there was a reason. Hang on. This is actually interesting. There was a reason I had 0, 1 here. Yeah, it's gonna work. Um, why I actually need to check that. Why did I have to put um 0? So I had to have I had to have a formula that does I no, it shouldn't. That's a good question. I don't know. It shouldn't need a cell. I think it has to do with running. Oh no, it's easy. It's because yeah, what we do after we set up this whole subject is we run the arm from four against it. Okay. Otherwise, we can't test if four works. So normally four would hold. Normally, this thing that I'm going to highlight 0, 1 dummy core, or sorry, like right here highlighting. Normally, that would hold a formula that basically the main logic, which says check if A or B is 0, otherwise, keep going. But in this case, we just want to see if it works like for deck A and deck B. And so we just have it be one that says whatever's here, um, just go ahead and return the whole thing for me again. Okay. So the way we can think of this is that we make this small like dummy core be the subject, Um, we go ahead and set it up with Deckgate, and then we run these formulas against it, and then we yank this arm out of 4 and run it against that whole thing. Does that make sense? Yeah, exactly. So if I didn't have it as 0, right, if I didn't have it as 0, 1, um, or if I had it just as 1, yeah, it would basically take a formula there, and it would be trying to run just 1 as a formula, and that doesn't work. Okay. So we're just trying to make sure that it can like give us itself back at the end after decrementing the value. That's really all we're checking here is the easy way to say it. So dummy core is also quite big if you look at it. So dummy core and Deckgate are about the same size. In fact, dummy core is just, let me make this window bigger real quick so we can see. Dummy core is Deckgate just with a 0, 1 added to the head of the battery and with like 3377 added on as a payload. Okay. So it's very small. And all we're checking here is that after we run, um, recur on it, we're really just checking does it decrement A and B. Yeah, exactly. It's exactly correct. And in fact, our main logic is not very long. Like 6 logic is always super easy to follow, and probably we'll just be able to blow through it right here. That actually is the next thing we do. We just do we do some 6 logic and look and notice once again we get to just do it against using values from that core, like this very predictable 6 slot where A is, right? So this one I think you can probably just like track pretty easily, which is we have a 6, we check if whether the value of A is equal to 0. If it is equal to 0, we return a 2 because it means A is smaller. Else, we again run a 6. Our condition is right here. So check if B is 0. If it is, return a 1. Otherwise, recur. Okay. So notice that, and this is a little bit a little bit weird. Our recur logic isn't so long. Like if we look at what recur looks like, it's pretty short. Okay, so that's what's going in at the end here because recur doesn't contain Deckgate. It only contains like calls to Deckgate in these two right here, which both extract Deckgate in 0, 5, um, and then like edit it and run its only arm, the 1 and 2, because it's a gate. So crucial thing here is that else recur, which we've already written and tested. Now we know if we actually think about it, if it was a real core and not a dummy core, it would be like a full formula to run. So if it was instead of being 0, 1, if it was our main logic, it would just run it again. You just put that outside everything. Oh yeah. So this is something that I think is actually going to be important. Notice that main logic wasn't our last step. Our last step is called constructing the core. Okay, which is going to be kind of the final thing that we run. So because remember our final thing is like battery is main logic and deck gate, and then we have our payload. So we're actually not done once we have main logic. What I do is I just put that test outside everything, construct the core, and run it. So main logic is pretty straightforward. I can make it the like what I do right here is I just kind of assume that I have this battery of main logic deck gate. I give it the values 9 and 10. And then what I do is I run 9401, meaning this thing is going to be my subject. So really the code could be more like AB equals, yes, correct. There's basically exactly correct. And not only is that correct, like that hoon looks like that knock. There's a very, very close mapping between the two. When even down to the fact that like this AB that you have right here at the end, if we go ahead and run it and test our three cases, we actually see that right here. Okay, so it actually really it even feels like that. So we can actually just go pretty quickly through this part here, which is essentially what I'm testing at this point. I'm going ahead and running the main. I first extract. I say give me 0, 1, so just give me the whole core, and then run main logic against it. And so as long as as long as they're not equal to each other, this actually works right now. Here it tells us A is less than B, and here it tells us B is less. A is greater than B, right? Because all we're doing is saying, give us this core and run main logic in it. And we've kind of done all the pre-work to make that work. So then we go ahead and everything else is pretty perfunctory. We make the battery and call it battery. We make the payload is memory slots 2 and 3. So what we do here is we do the test for whether slot 02 is equal to slot 03. If it is, we return that they're equal. And if they're not, what we do is basically we'll leave aside 9, 4 for now. We go ahead and construct, we go ahead and make a core right here, which is part of it is static, part of it is dynamic. Gave them equivalent there, you'd always get 1 because the first check is a 0. Wait, if you gave them equivalent, you'd always, yeah, I think if you gave them 9 as 9, yeah, you get that A goes to 0 first. Correct. Correct. You would get, we actually, I think, do I have, I mean, I can just, this is a nice thing of like putting all this stuff here. You can just like test it. Yeah, you're correct. It'll give us a 1. Essentially, it'll be saying that A is greater than B, even when it's not. So this one gives us like the 1, but if we make them equal, it also should give us what? That's actually interesting. It gives us a 2, which is A is. Oh, right. Sorry. It's giving us A is less than B because it thinks A got to 0 first. Yeah, I also thought 1. So maybe my numbers should be like different. Um, and so this part is we basically just go ahead and there's a static and dynamic component of this core. The static component is battery because that's always going to be the same every time through. It's just main logic and deck gate, which don't change at all. Those are just very inert formulas. And then our data changes on each run. So notice how that uses a formula. It extracts this. So we extract the 02 and the 03 to compare them. And then if we end up going to the core case, we extract them again, and now we have our entire core set up. And so we go ahead and knock it down with a 9, 4, meaning use the main logic. And again, it can feel a little weird that we're knocking it down with the 9, 4 and just knocking it down using only one of the arms. But that's exactly the same as a barket, right? Like you choose one of the arms, but inside main logic, inside the recur part of it, recur contains a reference to the other arm. And yeah, we see 2 and 3 of the subject. So notice how much easier this thing is to read if you skip the 9, 4 at first and just go and figure out that like, oh, it's doing a constant of the battery and then extracting those values. And then you're just like, oh, that's our core with specific values put in for A and B. Right? And then it becomes very easy to be like, oh, okay. And then we like, run arm number 4, aka basically a barket. So it really, and I made this mistake a lot when I was first doing Nock, but reading each opcode in the natural way for that opcode really helps a lot for quickly grokking it, like in 1 minute or 30 seconds instead of like 10 minutes. Quite literally in some cases. Under the third line, the construction of the core is interpreted as a cell. This is we could write this, but I think you're asking about this part here. Um, I mean, you can write it in the dojo, but this is the same as 03. It'll translate it. The key thing or the way to think about that part, and these are annoying for me too, is like brackets matter when they're after early things, is kind of the heuristic or the rule of thumb. Like a bracket after an early thing is meaningful, after the end is not. You can kind of play with this one a little, but the key thing is this is meaningful and this one really isn't. Yeah. Again, like honestly, I'm actually kind of bad with those, and I literally just like use something like that. Yeah, that's why. Um, I write them just alternately depending on what's easiest for me, like for meaning. And yeah, after we do this, if we make comparison be these things, like if I had done this thing with battery, and we set up comparison here, you can actually go and run it and look at it, and you actually the reason I like to do this yeah, I know. I think Palfa like hates a lot of what I say in general, so it's just par for the course. Um, so like the reason I kind of emphasize printing out this entire comparison thing right here is that in the same way that I was able just to like go find random code on the interwebs and modify it with like the decrement formula that starts right here, this now becomes an equivalent piece of like random code on the interwebs that we know always works as long as subject is in the same form, and we can do exactly the same tricks with it where we like turn it into a gate or something, or sorry, like an arm, and then from there a gate, which would look something like okay, so it would be like a 7, and then it would just be 0. Oh, it's kind of cool actually. Comp arm 0203. And yes, I could I could take out those parts of it, but I'm going to leave them in for now. 70203, and then run comparison on them. Um, or would I want it to be 0203? No, I would want it to be like because I want it to set up to do it for the sample, so it should be 0607. When you say composing two potential 2 and 3 positions from other expressions, which part are you talking about? This is just my own denseness. Yeah, I think what you're saying is like I can 2 and 3. I can so ignore the 2 and 3. That was a mistake. But essentially, I can like arbitrarily use this comparison formula wherever I want. And if I want to use it like in its raw, I'll call it like raw form where it goes against the subject, I can do that. Um, 6 7. I think it's 6 7 because like if you're gonna have it as a gate, the way it would look would be yeah. So what I'm doing is I'm saying I'm now making it into a gate. So then it becomes like, comp gate is comp arm, and then we'll give it like, a sample of 00 or something or something. Actually, that's exactly what it would be. And this is like live coding. So actually, and so comp arm 00. So it would be, and then you have to run it against itself. So we could run dot star. I think 920. We could just do comp gate 9201. So just call it on itself, and it gives 0. Yeah. And then we know all the things for like knocking out the formula, which would be again 92, but with like a 10 opcode to edit it. But the key insight here is that once I have it in this like big chunk of thing that works against like a very predictable subject like this, I can easily, trivially translate that into in first an arm by using usually seven to extract the data. Think of seven as extract the data from the sample and then run the thing on it. Oh yeah, so the thing that's super cool. He was misinterpreting it, and it turned out we were just talking about like arm and gait. Yeah, my like Janesian voices in my head that change the course of like what I'm writing. What do you like bicameral voices? That's what they are. I think like to be honest, that's it. Everything else is like building from here. That there's probably like a few cool, like really cool things that are done in Nock that I'm not seeing here, but we're like pretty far through it. I mean, this pretty much gives you enough intuitions to think of anything in Nock and like the ground under Hoon accurately. Is there anything else here that you kind of want me to go over? I was kind of trying to give a feel here of how each little piece you make expands very easily to more complex pieces, but in a very repeatable, predictable way. So the key thing about this thing right here is like there was like a repeatable, easy mechanical process for turning it into an arm and then into a gate. Yeah, good question. What's the longest thing I've written in Nock after learning this? You're looking at the longest things I've written in Nock. It's funny. Like I originally learned Nock literally because I had like time to kill because like our newborn had to stay in the hospital longer than anticipated. And so I was just stuck there. Like it wasn't like life threatening or anything. It was just stupid. And so I was just there and bored. So I was like, I'm gonna learn Nock. And then I was able to explain it decently, and so did this. But everything I want to do, like when I'm doing stuff, no, honestly, it helps me have various conversations about the system. It really just gave me a good feel for the inertness of a lot of stuff in Urbit, and like a good feel for like getting comfortable with the subject. And I honestly, it's I think Nock is self-justifying. It's like very cool and very beautiful, and I think everyone who's kind of done it and gone through it basically has the feeling like it's cool and very beautiful, and it helps me understand how things work, and then you go and like build the rest of it after. I don't think it's like for almost anyone who works with Urbit that I can tell, it's like not really like a forever stage. It's just like a very beautiful thing that's underneath all of it and that informs how you think about the rest. And that's pretty good. I do that said, I was interviewing like Robness a bit about some stuff, and I do want to like get a little bit more into the exact mechanics of how Hoon is built from Nock. But my guess is that it's going to be a lot like what we just did with like comparison gate, where there's initially like an intuitive leap that you have to make and get, and then it's like a very mechanical repeating process. Is how a lot of this works. Actually, one of the main takeaways I would have from this lesson, just for people reading the code and going through it, would be that like opcodes dictate the order you read. Like 6 reads left to right, 9 right to left. And we saw a lot of examples of stuff like that. Yeah, honestly, I'm just having so much like fun right now with Gall and getting into those mechanics, and figuring out the rest, that it's fun to actually do the real stuff and get better at that. Because I don't know, I spend so much time doing documentation and like reading other people's code and figuring stuff out, that I'm definitely like behind in terms of writing stuff. But it is what it is. It's pretty fun. There's a lot of fun stuff to explore, and everything is really cool. And I don't want to like go back to writing normal programs. So I think on that we could take the rest offline, but I'll leave it here. Obviously because of Urbit. Oh yeah, sorry. Last question. Go. Okay, what programming language do I know outside of this? Where yeah, I mean, one of those people who's programmed for, yeah. So, um, I started programming when I was like 15. I was homeschooled, and my parents just gave me an hour every day where they were like, "Tim Luke, learn to program." And this was like the mid late 90s, and that meant like you go to the library and find a book on C, and then start messing with it. So I was doing like C, C++, and nothing. I didn't build anything that remarkable. Did it in school, but and then did it in college for my major. But there, I was doing stuff. We mostly did like Lisp. There were a lot. There's a weirdly high amount of Lisp, so I was like decently comfortable with that. Also a decent amount of C, and then sometimes, like, if I, at the time, I was like, oh, if I'm lucky, I get to use Python. Then I stopped. So that was 2007. I stopped programming for about 5 years, and then picked up again in 2012, and was writing mostly Clojure, which is like kind of Lisp on top of Java, but basically lets you have like a Lisp experience while doing that. The thing I don't have much experience in at all, I've done a little bit, is assembly, and not that much C experience, even though we were doing some stuff in college. So this was actually very fun for me to do the assembly type layer, which I rarely do. I've generally been a much more like kind of, I don't know how you would say it, like lunch pail programmer, where I'm just working in like, okay, lots of backend stuff, DevOps, like make this thing work, write this like database code, um, some JavaScript and things like that. So it, Urbit is fun as hell for getting deep into like the roots of a system in a way that I just like haven't in Unix, because it's not really fun for me, and maybe the payoff isn't there as much. Um, I will say the part of my backstory that influences how I see this is the stuff related to Lisp, and also having done a lot of functional programming, and I have done some Haskell as well. So it felt really good and safe and comforting to have these like very predictable environments you can set up with the Nock and Hoon subject, and just like manipulate them very explicitly. That I really liked, and that was really attractive in Nock. And I've kind of tried to give that feeling throughout, where everything is really like inert and just data sitting there, and you can kind of work with it in little chunks and build it up. I like that feeling a lot. Yeah, it's like the 80s all over again or something. Like, yeah, no, and look, there's definitely a part of my kind of bio where I feel like I missed the various waves in like late 90s, early 2000s, and it's kind of fun to like get a wave. You're welcome. Obviously, you guys gave the universe, not me. So, thank you, and I guess probably see the next thing will be with golf, as we go into those lessons. So let's, yeah, we can kill it now.